This video brought to you by Louise R. Lester Foundation.
Hi explorers, welcome back. Twinkle, twinkle, luminous spheroid of plasma. That's not quite how the song goes, but that's okay. Have you ever wanted to explore the stars in the night sky? Well, I'm actually reading this really exciting book by Matt Fleanor, and in the book he talks about the closest star to the Earth. Do you know what it is? If you said the sun, you would be right. The sun is actually made up of a combination of gases, and those gases take the form of plasma.
Did I hear you mention the sun star? Hello, Payton and explorers. I'm so glad to be here today that I showed up a little early, and that never happens.
Explorers, let me introduce you to Professor Matt Fleanor. Welcome!
Hi, thanks.
We were just talking about the sun and how it's the closest star to the Earth. And you know, I actually am having a little trouble explaining why they can't see the sun during the night, only during the day. Could you help us out with that?
That's a great question, Payton. Day is caused because this one star, our sun star, is so much closer than any other star that we know of. The light energy from our sun star washes out all of the other light that we can see. Except for a solar eclipse, night is the only time that we can see another star. The day and night pattern is so important for all of life's functions on Earth. The spinning of the Earth is in fact the reason why we have this day and night pattern. This pattern of light and dark is essential for all of life's existence as we know it.
Well, that is really neat. Explorers, would you like to go on an adventure with Professor Matt to learn a little bit more? If so, you should go to centerinthesquare.org's on-demand page and get your free Explorer Passport. Remember, all you need to be a good explorer is an imagination, the willingness to learn, and the ability to ask questions. Ready to go? Let's go! So, Professor Matt, why are we here on the rooftop exactly?
Good question. I had something I wanted to show you that's right here on the rooftop of Center in the Square. Do you know what these are, explorers? That's right, solar panels. Did you know, Payton, that these solar panels soak up as much of the sun's energy during the daytime as possible? Some solar panels even move during the day with the sun's position in the sky.
Well, that is really interesting. So how much of the sun's energy does the Earth actually receive? And what do we use the sun's energy for here on Earth?
Such good questions, Payton. In fact, if I have a $100 bill and that $100 bill represents all of the sun's energy possible, only less than a penny actually is received by the Earth. A very small amount from the sun, but in fact, almost all of the energy that we receive on the entire Earth is due to the sun. And it's used for all sorts of things. Some are directly connected, like the plant cycle and the water cycle, and some processes are indirectly connected, like fossil fuels and the tidal cycle.
Well, that is really awesome. It's here! It's here!
What's here?
Well, let's go back to my office and I'll show you. Here it is.
Wow, a model of the solar system.
Yeah, I thought it could help us in our exploration of the sun star in our solar system.
Yeah, did you know that most stars actually have planets? Our solar system has 8 planets, of course, but lots of other things like asteroids, comets, and dwarf planets. Our 8 planets are divided into 2 main categories and locations. The inner planets, the first 4, are rocky and small, while the outer 4 are large and gas-like. Space scientists ask questions about how the solar system was formed based on the way the planets are arranged. The picture we are in now shows the first 4 planets at their approximate distance and size from the sun star.
Does it matter how far a planet is from the sun?
That's a great question, Payton. The short answer is yes, it does. Even though the sun star looks big to our eye, it is very far away. The Earth-Sun distance is sometimes called the Goldilocks distance, which is also called the habitable zone, because it is just right for water to exist. To our knowledge, no other planet has water and an atmosphere like the Earth. Water is essential for life as we know it. And for that reason, we must take care of the water on our planet. Other inner rocky planets like Mercury, Venus, and Mars have some elements for life to exist, but they are not located in a zone where water can easily exist. If our sun star was hotter, then the Goldilocks distance would be farther from the sun star. A planet like Mars might be in the Goldilocks zone. If it were cooler, then perhaps Venus would be just right.
So to go back through what we learned so far, the sun is very important to life on Earth, and our planet happens to be just the right distance from the sun. What else can scientists learn by looking at the sun and planets in our solar system?
That's a great question, Payton. In fact, we learn about all other stars in the night sky because of our sun star. These scientists use what is known about our sun star to make inferences about other stars in the night sky. The power of inference is extremely important to scientists and especially astronomers. Inference means that scientists make conclusions without direct observations of all instances.
Well, that is awesome. So what else can we infer by looking at the sun?
Another great question, Payton. One of the things that astronomers can infer about other objects in the night sky is the shape of the object. That's the reason that all other objects in the solar system appear as circles in the night sky. The sun star also spins on its axis and rotates like planets and moons. Our sun star also orbits or revolves around the center of our galaxy, as do planets revolve around our sun star. The inference drawn from these patterns suggests that the same forces and energy are present throughout the solar system and beyond.
So even though we can't actually travel to the surface of the sun star, we can learn a lot about what's going on inside the sun star. Could that be another example of inferences scientists can make?
That's right, Payton. There are 3 other example inferences that astronomers or space scientists make about our sun star. In examining the sunspots on the surface, we see that the sun rotates on its axis. We also see these sunspots change in shape and size. Sometimes we see lots of spots on the sun, and sometimes not many at all. This helps us to infer that the inside of the sun has convection. Convection is a way that heat energy is transferred, unlike radiation. One example of convection on Earth is the wind that is caused on the beach. The air above the sand is hotter and rises, which allows cool air from the ocean to breeze. Astronomers infer that the inner parts of the sun star are hotter, and when those parts rise, they form spots on the surface of the sun. Not only do we see spots on the sun star, but also loops and arcs. These loops look very much like the loops seen with magnets on the Earth. Although we don't go to the sun star's surface and measure the magnetic field, astronomers infer that magnetic forces are present. Some of these magnetic loops are bigger than the Earth. These magnetic fields also tell us that the sun star is composed of charged material. Only charged or magnetic material responds to magnetic fields in this way. On Earth, we know that there are 3 phases of matter: solid, liquid, and gas. Because the sun star shows many properties of both liquids and gases, but also charged solids, we say that the sun star is made of plasma. We have to create a new form of matter to better understand our sun star. Lightning is an example of plasma on Earth. So Payton, all of these examples of solar processes, convection, magnetism, and plasma, are also processes that happen on Earth. It's important to understand that the same processes that are happening on the sun star are also happening here on Earth in the same way.
So that means we can learn about what's happening in the stars just by studying things that are happening here on Earth?
That's right, Payton. As we continue to study, ask, and learn about processes on the Earth, we can actually learn more about the sky.
Well, I think that just about says it all, Professor. Now, remember to fill out your Explorer passports and send me an email of your favorite parts of the solar system. Happy exploring!